So, hello everyone. Today, today we will try to solve a div to B problem. And if you ask me the exact question, what was it? Is It was like it may be. I'm just. It was 2246 B 2246 B1. So what we need to do is the question is asking us to build an array of integers in such that the sum of all elements is divisible by its AI, and AI must be greater than 0. All elements all elements should be greater than 0. So this is the question, and we will be given n, which will be the size of array which we are going to build, and suppose n is equal to 3, then we have to build a array which will have 3 integers value, and each is greater than 0, greater than 0, greater than 0. And if we sum up these values, we will get a value p, let's suppose, and that p, when divided by these all elements, it will give 0 remainder. So this is the question, and we'll try to do this. So to solve this question, let's think about what happens when we were given n equals to 1. Okay, so suppose n is 1 we are given, and we have to build an array which will have one element which is divisible by that one element, and their sum also would be that same element. So it is very easy to build such array when the number of elements is only one. Like we can have any number, any n inside it. We can have 30, as the sum would be the same element. So no worry to think about what sum would be. Like this, there is a single element, and the single element is divisible by number is divisible by that same number, which is also true. So 30 is divisible by 30. So this is okay. When we are given n equals to 1, we are able to build an array. and that we can simply return a value integer. Okay, what about when we have n equals to 2? Let's see. uh, what about when we have n equals to 2? So we are trying to build an array where we'll have two elements. Let's suppose these elements are a1 and a2, and their sum would be a1 plus a2, and this sum gives remainder 0 when divided by a1 and a2. Okay, so let's think about this. Suppose we kept here 3. What else could be here so that this condition matches, this condition satisfies? So how to determine the value of which is going to be here? Suppose it could be anything. Like suppose you thought about 10. Okay, is it correct? Is it correct? So sum is 13, and it is not divisible by either by 3, not by 10. So we are going to understand this how we will decide that the element we are going to have at the second position as a second element of the array. How we are going to decide uh, which can be, and in this question, so let me go to the next page. Mosquitoes are, let's go to the next page. So basically we have to build an array where a2. Okay, so we have to build an array where we have two elements, and the sum divides by a1 will give 0, and sum divided by a2 will give remainder 0. So how to uh, how to find such array? For now, just think about building an array of size 2. Else you don't think about that. We'll understand it later. So basically, suppose you thought about any number. Let's suppose you thought about 100. Okay, so which element is going to be there? Let's suppose element p. What p should be, so that s is equal to 100 plus p, which is the sum. It gives it gives 0 remainder when divided by 100, and when divided by p, it should also give 0 remainder. So how we are going to decide? So suppose 100 plus, if let's think like that. Suppose we have a1 and comma a2, like these commas are kind of similar to one, so I would just take a comma b. These are the two elements, and we are trying to predict these two values which will satisfy our condition. So there, if you see here, will have sum equals to a plus b. So basically, for the sum to be divisible by at least a, it should be like a plus k times a. Means we should have a multiple of a at the second position. Like why this should be? Why this should be? Let me clarify that. Suppose we have second element as multiple of first element, let's suppose k times a, then we would have some a plus ka, and as we have a in both terms, that means it is divisible by the first element. Also we can have like this 1 plus k. So this is divisible by a because we have a as a multiple. So it is granted that we this is divisible by a. But what about ka? Is it divisible by ka? Is it divisible by ka? It is not. Yes, you can clearly see this. See this. We have a 1 plus k, and this is not divisible by ka. So when it will be divisible by ka? When what is the value of k which would make the sum divisible by ka? So let's suppose s is equal to a plus ka. Okay. So you thought about k equals to 2. Let's see. So we get a plus 3a. Okay. And we get 4a. 4a is not divisible by 3a. This is clearly you can see. So like I'll have to move to the another page or what. I'm just trying to uh, show something. Where is my, yes, here. So let's move to the next page. Let's move to the next page. So we had S is equal to K, no, it was A plus KA, and we are trying to find K such that S is divisible by KA and A. So it is already divisible by A, and now we are trying to uh, find the value of K, which will make it divisible by K. So suppose let's think about when K is greater than 1. Let's think about this. Okay. So when we have greater than 1, then S would be A plus value of K would be 3A. It could be 3A. It could be A plus 100A. It could be A plus S is equal to A plus 4A. So if you see at the as a second element in all possible values of k, we will have always always a greater a greater number than A. Yes, this is so direct. You can say that if you can see this, we'll always have a second element greater than A. This means this means the sum is always going to be the sum is always going to be not divisible by A. Why so? Let's see. Suppose why so? Why so? I mean, when we have a value of k greater than 1, then why the sum is not will not be divisible by ka? That this is so simple. Suppose let's say when you have two numbers and one is greater than one is greater than another, then we it is greater than b, and b is greater than 1. That means we will always left with remainder is equal to a. Let's have an example of that. So basically we're trying to, we can have example here as well, where it is. So yes, let's create a boundary line for this. So we're trying to, I'm just saying this, when we have s is equal to a plus ka, means the first element is a and the second element as ka, where k is greater than 1, means obviously the second element is going to be larger than the first element. At this time I'm saying this, that when we have two values, when b is greater than a, and either it could be the multiple of a, in this case it is multiple of k, okay, then we are not going to get remainder 0 when we divide the sum by ka, because this is simple. Like when we can have example, like suppose we have 3 and b is equal to we have 6, okay. Yes, we have here k is equal to 2. Yep. So sum would be sum would be 9. 9 means 3 plus 2 into k. No, it is itself k is equal to 2. So 2 into 3. And then we are going to divide it by 6. Then this will be divisible, but this will be left as a remainder. 3 as remainder, as 9 divided by 6 will give us remainder 3. So I'm just saying this, when we are going to have the value of k, where it is, I'm sorry guys. So I'm saying this, when we have the value of k greater than 1, then we are always going to get the second number as a larger number, and we are when we sum up these two number, we are never going to get a remainder 0 when it is divided by k, the larger number. So we can't have the value of k greater than 0. This is proved. If you have any confusion, you can ask me. So it's just so simple. Suppose we let's go to the another page. We try to build an array which there are two elements, and To make it divisible by these two elements, we do this. And for now, let's do this. I'm just talking about this. I'm not talking about anything else. So I'm just trying to make it divisible by these both elements. So I did this. At least here, this is divisible by the sum, which sum is a plus ka is divisible by a. Okay. Yes. And what I previously said this that when we have k is equals to 1, we are always having second element. Let's suppose it as a comma b. We are having always b greater than 1. When we have this, and sum would be a plus b, and b is greater than 1, then when we divide yes by b, remainder will be what the smaller number. Okay, so I just said about that. So we can't have the value of k greater than 1. Are you clear about this? I think this we try to keep the value greater than 1, and we didn't found it as it is not divisible by the second element, the larger element. So we can also have an example of this. Let's suppose you thought about 10, and we let's suppose 3, which is 10 comma 3 into 10. Okay, so the sum we are going to get is 40, which is 10 plus 30. It is divisible by 10. It is for sure. It is divisible by 10. But let's think about, we can say here, we are when we divide it by 30, we are going to get remainder 10. So we can't build an array when we have to build an array of size 2, and we have to take the different two elements, and basically one is the multiple of another, and which is the larger than others. So what else value we can have? Now, to build an array of size 2, what else we can have? Okay, a comma ka. What else we can have here? Let's think about what happens when k equals to 1. The array would become a comma a, and we will end up with sum 2a, and this is divisible by both a. Okay, but we are not allowed to have this. Means we can't have duplicate values. I think I missed this information to put at the beginning. So we have to build an array such that each element must be different, and so here this is not true. We are not going to have. Let's suppose what happens when we have 0. So our array would become a comma 0. Here also sum would be a, and this also satisfies. But our question says each element should be greater than 0. So this array also can't be. This is not valid. Valid according to, not invalid. Invalid according to question. Okay. So what else we left with the values of k? Let's suppose we have a comma ka. We can have k values less than 0. Okay. Like we can have k equals to -1, then we will have a comma minus a. The sum would become 0, and 0 is divisible by both this. 0 percentage a gives 0, and 0 percentage minus a gives 0. This is also true, but here also we need each element greater than 0, so this also not doesn't satisfy. And k equals to -2, this would apply to the same thing that we when we had k greater than 1. So here as well it would let's have an example. So like a 2a, and it would become -3a, and when we divide it by it is divisible by a, but -3a is not divisible by -2a. It would give a as a remainder. What would it give as a remainder? Let, let's have an example. Suppose we have 3 comma -3. Okay, no, it is -6. We know this array is not valid, but I want to just verify this when the one element is a and another is -2a, then what is the remainder we are going to get when we divide it by this number? That is smaller. Okay, like I just got confused that later I told you when we have two number, one is bigger than another, then if you divide it by bigger number, we are going to get a remainder as a smaller number. But in this case, are we going to get the smaller number as a remainder? Let's see. The sum would be -3, and when we divide it by 3, it would give remainder 0. But what would happen when we it would give a remainder -3? Yes, yes, it would give a remainder -3. Like would have -6 and a -3 and 0. So 0 -3. Yes, -3 remainder will get. So for this as well, we are not going to have an array. So basically, we tried all the possible values which could be these two values, but we are not going to get this when we have to. Means we can't build an array, can't build, we can't build an array when we have to build two, we have to take two elements, and the two elements must be different, and this must satisfy this condition. So we can't build the array. So what we will do now is, let me add some pages. We can't build an array. Did you get it? Like we can't build an array when we have to build a size of array 2, when we have to take these two elements different, and like we can't have it. We tried it. Yes. Also, we don't have the another number as a multiple of others, we wouldn't be able to create such array. Like either we would have to take this one or that one, and that involving zero, I think. Yes, involving zero. This one, like this one and this one. This is valid, but this is not allowed in this case. So for array 2, we can't build such array. Okay, this is clear. I think this is clear. You might be thinking like there is, if for n is equal to 2, why we are going to take always this one? Because if we took another than this, then it wouldn't be divisible by a. Like we're trying to achieve the second number such that we are such that the sum is going to be divisible by a. Like, is it anything else? Like 1 comma 3, it also no, no. Okay, like what if this is the second number is not multiple of another, then the sum is obviously. You might think that why we are going to why we did so. So suppose you try you have another number, let's suppose p, and that p is not multiple of p is not multiple of k times a, then the sum would always be a plus p, and this p is not multiple times multiple of k. That means the sum is not going to be divisible by a always. So this the first condition itself is terminated. So that's why we took first element as any elements and second element is a multiple of it. And to satisfy this condition, we are not able to build such array. We were able to build such array, but like a comma 0 or a comma minus a, but this doesn't uh, fulfill our questions requirement. So for n, the answer for n is equal to 2, the answer would be -1, means no such array. I hope you got the idea that how we are not going to get the array when we have n equals to 2. Now let's move to another page. And what happens when we have n equals to 3? Let's see. You might be thinking like why I'm checking by n is equal to 1, n is equal to 2, n is equal to 3. How these things would come open into my mind. So I did try at first and try at first, but I built it with like that one with involvement of 0 as element, which we are not allowed in the question. And uh, I also solved using not solved. I also, like initially I did when we have 3, then I would just involve it as 0 and another as 3 and 3, and then sum would be 0, and it is divisible. The sum is 0 and 0 is always divisible by any other number. So I was always thinking that let's make sum 0 and it will always be divisible by any other number. But to get sum 0, we would require 0 as element and negative, which we are not allowed to have. So yeah, that was another thing. So that was the thing that I did. So I just told you. So let's try for n equals to 3. We will require a comma b comma c. These are 3 different numbers, and the sum is divisible by this. So How we are going to get this? How would you think about this? Means suppose when S is equal to A plus B plus C. Okay, S would be A plus B plus C. I need this sum. I need this sum divisible by A, B, and C. Let me have you an example. Suppose when we have n is equals to 12 and when we can say n is divisible by 4. When we can see we can say n is divisible by 4 when जब k times 4 equals to n means 4 must be present inside the factors of n. 12 equals to 1 गुने 2 गुने 3 गुने 2. We have 4. 1 गुने 3 गुने 4 means 3 into 4 equals to 12. Okay, so we have this 4 present inside this. Then we can say that this number is divisible by this number when it must be present in this. So here we will apply the same thing. We'll think that uh, how we can make the 2 be divisible by the sum value must have a into something, let's say p, and 2 divisible by b, it must be a into b, let's say something k, and 2 divisible by c, it must be a, b, c, and nothing left, so 1. Means when we have sum equals to a, b, c, then it is divisible by a, b, and c. Okay, so we are trying to find such values of a, b, and c such that their sum is equal to product. Their sum a plus b plus c is equal to product, which is a into b into c. How we came up to this? Because when we'll have this, then it is automatically divisible by these 3. So that's how we came up to this. So let's build an array where the sum which satisfies this. So how from here we can write it as like this, and basically we can derive an equation from here. A plus b, like we can let's find the value of one thing, like a plus c equals to a b c minus b, or a plus c we can have B as a common, AC minus 1, and therefore B would be A plus C upon AC minus 1. Okay. So what are those values? Whose sum is this, which sum is equals to their products. So suppose let's have A equals to 7, B equals to 7 plus, and let's have C is equal to 6 upon 42 minus 1 equals to 13 upon 43. We are going to get in point. So this is not valid. The value of C is equal to 7. No. A equals to 7 and B, sorry, C equals to 6. This is not valid. So we're trying to find the value of A, B, and C which satisfies this equation. Okay, let's rub it. If you if you are writing on the note in your copy, then you should also try out which value would satisfy and why it would satisfy. Why other values will not satisfy. And remember, we have to find integer, not a decimal number, like a point wala number. So if you clearly, if you let's have A equals to 4 and C equals to 3, and what value we will get? 4 plus 3 is 7 upon 4 3 is 12 minus 11. Also we are getting in point, so this is also not valid. Let's have uh, let's try to have multiple of others. Okay, 36 multiplication would be tough. A equals to 3 and B equals to 9. So we'll have in numerator 12 upon 27, 26. Also we are going to this. So if you see in past three examples, we were always getting denominator bigger than numerator, which lead us to getting floating number. So floating point number. So we will try not to have denominator greater than the numerator. So what else we can have? Suppose like this AC, and also uh, this AC must be greater than 1, because if AC equals to 0, it no. If AC equals to 1, it would make denominator 0, which is not what we want. So keep it in your mind that AC must be greater than 1, not 1 equal to 1. And also you can't you can't have 1, because if when we are going to get 1 when we have A equals to 1 and C equals to 1, considering that we are just taking integers value, and these are not allowed as it will have duplicate values. So what else we can have? Which value? Which value is? Which two value is? What are those two values whose product is? Whose product is either same as the sum or less than the sum? So less than the sum, this doesn't make sense. So except one. So uh, so we can have A equals to 2 C equals to 1. Their sum would be 3 and their product would be AC would be 2. So these are the two numbers which sum is greater and product is less. So here what we would get from here is, let's move to next page. We had B equals to sum of these two numbers and product of these two numbers minus 1. So we took A equals to 2 and C equals to 1. So we would get 3 upon 2 minus 1 equals to 3. So yes, we got a good combination where A equals to 2, B equals to 3 and C equals to 1. So when we have these three numbers, then the sum is 6 and it have all the factors which is each element, and obviously it is divisible by 6 all the elements, so this is valid. We can, and this let me talk about one thing. The equation we talked about, this one, like this is the condition we found out that we have to do this, we have to find this to get this one. So this equation is symmetry. This equation is symmetry. What does this means swapping values of each variable with others will not impact. Means here we have A equals to 2 and B equals to 3 and C is equal to 3. If we try to have A equals to 1, B equals to 2 and C is equal to 3, means we swap the values of A and B. No, we swap the values of A and C, and then we swap the values of B and C. Okay. So here also we'll have some 6. So symmetric means this: when we swap these values, when we rearrange the elements, when we swap the values, the property which the equation is giving, that will not change. So now what we will do is we'll seek a pattern here. See, so yeah, so we had S equals to 1, 2, 3. We found out 3 elements such that which sum is equals to its product, and how we found that we talked about it. Okay, we can see here we have 1, 2, 3. Okay, basically we have a comma 2a comma, and what is this, the sum of these two, 3a. Okay, isn't this? Yes. So how this satisfied, we'll try to prove that one. How this satisfied? A plus 2a plus 3a, it would give us 6a, and which is 2 times 3a. Basically we are in suppose here we have 3 elements which sum must be divisible by these 3 elements, a, and another is 2a, and another is 3a. So we are including some, we are having multiple of first element as other elements, so obviously we are going to get, divisible by a, and then remaining is this one and this one. So at the third place, we place the value, the sum of these two values, which is 3a. So also divisible by this one, also divisible by this one. And when we have a comma 2a comma 3a, then the sum would become 2 times of this place 3a, which we required these two as a factor in S, and that we got from adding the sum of these two elements here. So basically, intentionally, why? If you would ask me why I took second element as 2 multiple of a, there is a reason for this, because this is the this is the multiple of a, which is going to you get you the satisfy all the conditions. Rather than 2, you can't do this. And to how can we prove this? Let's suppose you take a plus 3a instead of 2, and as a third element you took the sum of these two elements, which is 4a. And when we sum up these all, we are going to get 8a. So basically, we are not having this one as a factor in the sum. How we could have, like we can't have, when if you put here 3a plus 4 2a, then only we are going to get like a plus 3a plus, if we put 2a, then only we are going to have 6a. Else we can put 3a plus, what else we can put, like which will result to another multiple of 6, another multiple of 3, like it's the 3 times 2, which is 6. So 3 3 is a 9. For 9a, we'll have to put a 5a, which is not going to, which is not good. So what else we could have? A plus 3, a plus 9, 27. For 27, we could have 12, 8. We're not going to get 8 in this. So this also the this also not satisfying. So basically, I want to say this. This is the only condition. This is the only condition which will satisfy this situation. The questions that is asking, and that we saw before as well. So for n equals to 3, you took any value of a. Suppose I took 4, and then I took twice of it, 8, and then you sum up these two values and write it as third value. So which is 12, which is, this is 12 plus 12 equals to 24. Also divisible by this, also divisible by this, also divisible by this. And how we are getting divisible by each of the elements, we already saw this. Like we are including a in each element, so it is already divisible by a, and we are summing these two elements and putting it as a third element. So uh, and when we sum all the elements, we get 2 times the sum of the first two elements, which is 3 times 2. So we are getting a 2 as a factor in the sum, and then it is all divisible by it is all divisible by each elements. Okay, so this was the case. Now what we will do when we have what we will do when we have n greater than 3. Okay, so first build 3. You can start from anywhere. Suppose you thought about starting from, let's say, 5 5 10, and 5 plus 10 15. So this is when n equals to 3. Suppose n equals to 10, you were asked to build. So 5 comma 10 comma 15, 15 15 30 and 30. Yes, okay. So which number you want here? How you are going to decide? Like, you decide like this: a comma 2a comma 3a, and the sum of all these elements. 3 to 5 is 6a. Then sum of all these elements, 12a. Then sum of all these elements, 24a. Then sum of all these elements, then 48a. Then 96a. Then x over c, 192a. Then 4 से 400 minus 16, 184. 384 a 4 4 8 9 10. And like when we have this is the sum, plus 192a plus 384a. So basically this value this value is equal to the sum of this value, 384a, and the sum would become 2 into 384a, and the all the factors all the factors are going to be this one. All the factors combination are going to make these all values. This one, this one, this one. You can check, like 384. You can try. We have a 2 into 384. What would a 2 into 384 into 2 would be? 4 to the 8, 4 to 16, and then 4 and 768. Okay, so 768 would have 2 गुने mosquitoes. So 76 would have 2 गुने 384, which will be 2 into 2 into what was it? 192. So 2 गुने 2 गुने here for this, then for this, then for this, then for this, then for this, Now we have to activate and contact and remaining is. So we are going to, we have a, okay. So we are going to have two. We have three. We have six. We have 12. We have 24. We have 48. We can get 48 as 840. This one as this, okay. 96. This all things. So all these are present as a multiple of these. Okay. Okay. So these are all are the elements which sum contains all the which sum contains all the factors of each term, which sum can have all the elements as a factor. We can say that. We can say this. So when we have to build n equals to 10 of size array, then 5 3s are 15, and then we can have double of this. This is 30, and then 60, and then 120, then 240, then 480, 448, 480. Then we can have 900, 960. We can have 1820. We can have these elements where the sum of the array is divisible by each element. So this was the all thing. So this was all. I hope you understand. This was my first try to teach something to you guys. I know I humble a lot, but it's okay. I just okay. Like I did the questions today. I did the question today, and previously I had solved that question, but I again after so many days I did it today, and I got to know about this all. I did it by my. I did it, so yeah, right. So when we have n equals to 3, we can follow the pattern. Take value of a as you desire, as you wish. 2a, 3a, 6a, 12a, 24a, and 48a, and double of this. Okay. So yep, I hope you got the idea about this, and let's write code. So this was like we would have. Let's suppose let's start from int main, and we will need a test case int, and I didn't talked about time complexity, and it is good for this problem. We don't have to talk about that. We don't need to talk about that. And for each test cases, we need n. Get me n. Okay. And if n equals to 1, then I would just let me know this. If when n equals to 1, I would just simply say out 1. That's so simple. Like you can see out any elements here. You can also, like I can also see out 9. That's okay. and else if when n equals to 2, then cout minus 1, or we are not able to build such array. And then at last else if it is greater than 3, it is greater or less than 3. Suppose so we assume this, we already built this one, or a comma 2 a comma 3a. So suppose when n is equals to 3, we would like to know what is the next number of elements we require. So as when the input will be 3, we already have 3 elements. So we just reduce, we'll will have, this is the required, like I reduced minus 3 because I have already minus 3 elements. And then while n minus minus, and also we'll start from a value 6a. So so here we can also see out, see out see out what you can take a value of a anything. I will, let's start from 3, then 3, then 2a, then 6. Let's have some space. Then 6, and then 3. 3a means some of this, that is 9. And then while n minus minus, and then if we require, if the num if we require more elements, then as the value may get much bigger, so we'll use a long. So long, and the fourth element would be the sum of all these, which is 6a. So here a is 3, so I would just take 6 into 3, means 18. Okay, and for, let's have another page, and then while n minus minus, cout p, and at last cout. Okay, yes, that would, I hope so. So yeah, this was all the, I tried, but it's okay. Bye.